Wait. What's in here? Oh my goodness.
How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we're going to be figuring out what's wrong with the MOAC. Now that we've got that job out of the way and back to the customer, before the next blade tilt cylinder turns up, I want to find out what happened and see if we can fix it. So the first thing I'm going to do is put a dial indicator on the top of the cutter to see how bad it is. So as you can see, it has 0.25 of a mil run out. So now what I'm going to do is unbolt the cutter plate off the arbor so I can put a straight edge across the center of it and check it for straightness. It's not bent. 0.25 mil, which is that thick. .01. No chance. So the plate isn't actually warped, it is very straight, and that is very surprising to me because I bet my money that the tufftriding had bent the material because I know what a little bit of heat can do to a piece of plate. But that's good news, that means the cutter is straight, so we can eliminate that from being the problem, but that means it's going to be the spindle or the arbor. So obviously it is not the spindle. I do use this machine very often and I know it is dead straight. So that means it's going to be the arbor. So what I'm going to do now is put a dial indicator on the bottom face of the arbor. We'll spin that up and see if it's got any run out. So it looks like we found the problem. The dial is showing there is 0.08 of a mil of run out. That is not as much as we had when the cutter plate was installed, where we had 0.25 of a mil, and that just shows how much the run out can be multiplied based on the diameter of the cutter. But what I'm going to do now, I am going to take the arbor out of the spindle. I'm going to clean everything and make sure everything's nice and clean and there's nothing on them, no burrs. We'll put it back in and we'll check it again. So the arbor is definitely the problem. Every surface that I put the dial indicator on showed that there was run out. That is pretty surprising, but I don't know the history of the arbor. I did inherit it with a heap of other tooling, but it did look brand new and hadn't looked like it had ever been fitted to a cutter before. So as far as I was concerned, it was brand new, but clearly it has a problem. So we do have a few options. I could recut the face where the cutter bolts onto, and that means it would then spin flat, but we also have the problem of the spigot on the arbor going into the plate, means it wouldn't spin concentric because we have run out there. Another option would be to buy a new arbor, but I haven't been able to find one online. We could also make one from scratch, but I don't really have the time for that. So what I'm going to do is get it out of the mill, set it up in the lathe, and recut that 50 taper, and hopefully that will eliminate all of our problems. Before I set up the arbor, I do need to set the compound, and to make sure I get the angle of the taper accurate, I'm going to be using a brand new holder. So that's dialed in. We're just going to lock down the compound. Because I'm using a 3-jaw chuck, even though I know mine are very accurate, I am going to machine up a fixture, so that way I know it is perfectly concentric with the chuck and on center line of the machine, and that will give us the best chance of getting this arbor being spot on. So we are still seeing run out on those outer diameters, but that's not going to be a problem because we can see that the face that the cutter bolts up against is running perfectly true. And now it's going to be interesting to see how much run out is on that taper.
It's not even that bad. That's surprising.
Let's go down here.
Oh. .08, that's what we got on the bottom. Right.
So there you go, there's that 0.08 of a mil run out at the top of that taper. Now what we're going to do is recut it. So I've recut the entire length of that taper, but I'm not entirely happy with the surface finish, so I am going to increase the RPM and I'm going to use some cutting fluid.
Right.
So we've done everything we can possibly do at this stage. Now what we're going to do is get it out of the lathe, get it set back up in the mill, and see if what we have done has solved the problem.
Hello. Russell. Yeah. Come here. George. Bye. Very cute.
Righto guys, so we're not getting 0 run out, we are still getting 0.01 of a mil, which is a lot better than the 0.08 that we started out with. And we know that is multiplied by about 3 on the outside of the cutter, so 0.03 of a mil, I'm pretty happy with that. Now we've done pretty much all we can do in order to get this running perfectly, so now what I'm going to do is put this back together and we can give it another test run. And what we're going to be using to test it is a scrap piece of 350 grade plate. So we are going to start with the same parameters as what we finished with on the last job, which is 63 RPM and about 5 mil a minute feed rate. So I'm going to continue to increase the feed rate until we find a happy spot where all of the inserts are engaging. It'll be 36 mil a minute.
So you were at 56.
Going up to 72.
Whoa, that's a big jump. Okay.
So that's our first cut done. We only had about 80% of the inserts engaging, and that was at a feed rate of 72 mil a minute and an RPM of 63. So for our second cut, I'm going to increase the feed rate up to 92 mil a minute and the RPM up to 73. And hopefully we'll get all the inserts engaging and we'll see what sort of surface finish we end up with.
Very aggressive.
That's not cutting real nicely, so I am going to increase the RPM up to 88. So you can really notice a difference when we increase that spindle speed. Unfortunately, we still don't have all of the inserts engaging, but this is far exceeding what I had hoped it could ever do. I was hoping to run this at about 50 mil a minute, about 100 RPM and a 1 mil depth of cut. And at the moment we have doubled that with our feed rate, which means we can get jobs done twice as fast as I had originally planned. But now I want to test it to see what sort of surface finish I can achieve. So I'm going to increase the RPM and lower the feed rate and take a 0.2 mil depth of cut. One insert doing all the work.
It looks pretty smooth.
It's not.
Oh, smoother than this though.
107. So we are getting a much better surface finish, but only one or two of the inserts is actually doing any work. So what I'm going to do is put a few yellow marks around the plate, and then we'll use a slow-mo on the camera to find out which one's doing the cutting. So now we've found out, we're going to get that insert out of the way, and I'm also going to slow down the RPM to 73 to see if we get better results. Righto guys, so even though this wasn't designed as a finishing tool, it is still leaving a pretty good surface finish. So with all of the testing, we were only able to get about 8 of the inserts engaging at any time, but I'm going to put that down to manually machining this in the mill using that rotary table. It's not designed for super high precision. If we had a super indexer that size, it would have been a lot better. But overall, this has far exceeded my expectations. We did overcome the problem with the arbor, and we are able to feed this at twice the feed rate I expected, and that means we're going to be able to get these jobs done a lot faster. So overall, this one's a win. So that's this job done. Hope you enjoyed the video. Thanks for watching. And the next thing I'm gonna... So the next thing I'm gonna do here.
So now what I'm gonna do?
Now what I'm gonna do.
Oh my god.
Right. So now.
Righto, guys.
Yeah, I know that bit.
Oh, you said you got this. Go.
Put on
Yeah.
tripod. Righto. Ready?
Yeah.
Righto, guys. So that is not zero, and that was at a feed rate. What's the feed rate? So the next thing I'm gonna do. Oh wait, what'd you say? It will be interesting to see how much run out. Righto guys, so we can see it is not perfectly 0.0, but it is only about 0.01 of a mil, which is going to be a lot better than what we first started with.
Not gonna, which
Right,
is.
Right, which is going to be a lot...
No.
What?
Which is a lot better.
did
It's
say
not.
that.
No, you said gonna.
Right. Which is going to be... Trying to put
Bent it.
back. See that damage them.
Oh,
Oh, I kinked it.
it's so delicate.
It is.
There we go. What is wrong with your dial? There we go.
So
Did I mention Toyo? Okay,
Yep.
it's the user, not the dial.
Let's see here. Dickhead.
Oh, you know what would have been interesting? What if you... Oh, that doesn't really matter because it's a taper. I was going to say... Yeah, now put a dial on taper. Oh. Good thing I'm here. It's a new extension up. Stand back, way back. That flew a long way.
Like that's a decent bit of sport.